discontinuity in number two?
No. Now, the way we tell if there's a point of discontinuity is when you factor. The factor that is common for numerator and denominator that you factor out is your point of discontinuity. Because anything in a denominator is an x value that you cannot use. Now, what's left in the denominator will be an asymptote. What we factor out of the denominator, we still can't use that one little point. So that becomes a point of discontinuity. Now, it's very hard to see it in your calculator because your calculator makes a continuous looking graph. It doesn't have enough space to jump over that one point. You mostly see it in your table, if you look at your table. I'm going to try to pull my calculator up. We'll do the first one together and see if that's helpful. So were we all okay with this one? This was your regular describe. Your regular one to describe. Okay, again, make sure your x-intercepts are zeros of your numerator. Your y-intercept is when x equals 0. Go back to your original 1. Plug the x in for 0. Okay, this was not factorable. These just say this is 2, x plus 3, x plus 3. That's all that means when we say the square. It's just the same factor twice. So we've got one intercept, one asymptote here when x is equal to -3. It doesn't come out twice, it just comes out once. I find the asymptotes, I like to draw my asymptotes first and then sketch my graphing. I think it makes more sense. But if you do it the other way, that is fine too. Good? Good? Alright. Let me see where there's a nice one that takes a point of discontinuity out of here. Okay, this one is a good one. Let's walk through this one. First step, always factor. Factor first. So we factor the top, we factor the denominator, right? Now, the denominator is what runs my domain. Take these factors, set them equal to 0. Those are the numbers I cannot use because I cannot divide by 0. It doesn't matter if it's an asymptote or a point of discontinuity. Right now, I'm just going to set them equal to 0 and say, well, I can't use 4, I can't use 5. I take them out of my domain. If it helps you guys, do a line out like this, because some of you are forgetting this middle piece. You can use there, and the middle piece. Okay, there's your domain. Now, reduce your fraction. This is the part that's coming out. Immediately circle that. I do it immediately because you know why? I forget to go back to it. I circle it and I bring it off to the side. This is going to be my point of discontinuity. Because even though we factored it out of your denominator, it won't become an asymptote, but we still cannot use the point x is equal to 4. It'll still give us an error. Now, rewrite your fraction as to what's left. This is after factoring it out, after reducing. This is the one you're going to work with from here on in. Now, you found your x value to be a 4. And in your graph, you cannot tell that it runs right over where 4 is. The only thing in your table is you can see 4 and 5 say error. So we realize 5 is making end behavior, is your asymptote. 4 is a point that it's jumping over. At the end of this course, we tie all this into calculus. It's a limit. Now let me show you a little trick on your calculator. If you put x equals 4 in your calculator, it'll be like this. It'll say y, nothing. It doesn't have the value for y. You can't put x is 4 in here. Now, it reaches a limit. Like, what could we replace this with? If we were going to be able to fill this little dot in, what would we fill it in with? If you look for x is 4.00001 and x is 3.99999, you would get very, very close to -2, right? If you put it in your calculator and you take a look at this. So what this is 4 approaches -2 from either side. It's a limit. As this function approaches 4, the limit, the value of y, will be -2. It's a replaceable point. I can take this out and replace it. An easy way to find this algebraically is to take your factored form and substitute in 4 into your factored form. That's how I knew it was going to reach -2. I looked to see what would that point be if in fact I could fill that little dot in. I want to be able to fill this little dot in so that now I will be continuous. What would I fill it in with? This number right here will fill that point in. That's called my point of discontinuity. I was clipping along here, then I had to stop, jump over, and continue. So if I could fill that in, then I'd have the point for -2. That's my point of discontinuity. Now, that point of discontinuity comes back to haunt you a little bit because now when you look for your, let's look at your other things, your vertical asymptotes. We're looking at this piece right here. Find your denominator. Use your original. You have an x over an x squared, so you automatically, for your horizontal, get the y equals 0. It gets your x-axis, right? Go back to your original for this one. You have no slant. Here it is, and you can kind of see it in your graph. Now, x-intercept, 0 of your numerators. Look what's left. Are there any zeros left? Any variables left in your numerator? None. No zeros of your numerator. For your y-intercept, plug a 0 in. Plug a 0 here. -8 over 20 reduces to -2/5. And yep, I can find this on my calculator as well. I can see that point. I can see I have no 0 intercepts. I could find my y-intercept. Agreed? Okay, now, here's the problem. Increasing, decreasing. You have to be able to take, and your range, you have to be able to take this point out of here. Your range says you can use all these numbers except 0. But guess what? We also couldn't use -2. If there was anything else down here, it would be okay, but just that guy right there, we can't use -2. You'll never use -2 because we can't technically use 4. So you've got to also take -2 out of your range. That's your point of discontinuity. That's the point that you discontinued your graph at. You stopped it and jumped over it. So technically when I do this, I'm coming to my y's, I stop, jump over where it's -2, and continue. This point right there that I jumped over was y is equal to -2. So you also have to take that out of your range as well. We took it out of your domain because we did your domain restriction first. So it's out of your domain. And therefore, if I'm increasing, decreasing, this is a decreasing value, we have to take the x value out of there as well. But that you can know from your domain restriction. We couldn't use x as 4 because we took it out of here, didn't we? We took it out of your domain. The tricky one is the y. Because your domain tells us, oh, you couldn't use 4, oh, you couldn't use 5. It's the range you have to be a little careful with. That one comes back to haunt us a little bit. And then concave down, you also have to take it out of your concavity as well. Take it out of your concavity. It's just kind of like you're just jumping over that point. Does that make sense? Yes? Questions on this? This is actually calculus. We're reaching limits. So calculus does limits, integrals, all those nice little fun things. These are your limits. Because I don't have a point, if I could reach that point from either side, the left side, the right side, it would converge right there at the -2 when y is -2. That's my limit to this function when x is 4. So you're actually doing calculus. In our very last unit, we revisit this again, and we put the calculus part words into there. We use the calculus words. Yes, see how smart you are? You didn't even know you were doing calculus. Okay, so we take a look at this, we factor everything. Let's get your factors down. Factor, factor. Everybody can factor? Factor an x out of your denominator, then factor again. Now, before you do anything else, find your domain. Those are all the x values that you cannot use, regardless if it's a point or an asymptote. So take this out of your domain. It gets a little bit cumbersome here. This is probably the hardest one you'll get. It's got a lot of things going on. Now, after you take out your domain, reduce this. We're going to take out this factor. This is going to come out. So this guy becomes your point of discontinuity. You can't just get rid of it because it's a point you can't use. You can never use x is equal to 3. So you technically can't get rid of it. So we just isolate it as a point. And we say, okay, what would the y also be? Did we do this one in class? We did this one, didn't we? Yeah, I think we did this very one.
You sure?
Yes, because I remember the 115.
Oh, but I look,
Yeah. So now, when you do this, watch. You'll come to your factored form, you'll plug in your 3, and you'll get your y. This point does not exist, but it's the point that we could replace that with. You mean you all did it and it was the one we did together? Aw. Now, go back to your vertical asymptotes. Use your factored form. Give me your vertical asymptotes. X is equal to 0. Here's your denominator. Your rule, your x2 over x3. Therefore, you have no slant because the top has to be larger. You automatically have your x-axis. I'm going to give you this sheet to walk through on your quiz tomorrow. You can have the sheet in front of you. I think that's probably an easier way to get an understanding. How is that? Up there? Oh. Okay. Now, relative means relative mass. Anything that turns has a min or a max. This guy over here keeps decreasing. That has no min or max. This one has a min. Is it the minimum point of the whole graph? No, so it's a relative min. This one has a max over here somewhere. Is it the maximum point of the whole thing? No, so it's a relative max. That's probably very, very close to where your point of discontinuity is. Actually, your point of discontinuity is a little bit before it. Because your relative max is at 4, and we're at 3. We're at 3 for our point of discontinuity, and your relative max is at 4. Now, here's a good example where your graph, your function, crosses over a horizontal asymptote. But watch what it does. Even though it crosses, it comes back up and comes back down and rides along that axis. That asymptote still defines your end behavior. It just jumped over it for a little bit. It can jump a horizontal because that's the zeros in your numerator, not your denominator. Excuse me. So you can jump over them. But the asymptotes are designed to guide your graph. That's your end behavior. So even though we jumped over it, it still guides my end behavior of my graph. And again, just be careful of that point of discontinuity, that you take it out, and in your range, that you take this out as well. I did it as a decimal and as a fraction in case you bring it to a decimal. If you bring it to a decimal. I always like to check on the calculator. I'll put in a value of 3.00001 and see if it's giving me very, very close to that number. Because 3 won't show up at all because you can't use 3. So everybody kind of seeing what that point of discontinuity means? And to look at your graph, you would never know it because your graph can't get that defined. You can't jump over that one little tiny point. You probably notice on your graph, sometimes your lines are like even off the way they make the graph. Questions? Is it you're just quiet because you want to get this over with? Or do you not have any questions? You, Aaron, you just want to get it over with? This really is not that bad. It's not that bad. It kind of does make sense, doesn't it? I think this math is very sensible. Let's just jump back to number 1 for a second, guys. Number 1, oh, did we do this one yesterday? Is that why we didn't do it? No. Let's take a look at number 1. We have plenty of time. Let's take a look at number 1. Everybody, let's work on number 1. As a matter of fact, let me pull up the other one and we'll work on it from scratch. How's that? All right. Tell me what I should do first. Factor. So what does my numerator factor into? X minus 4x plus 2. Yeah, you need the minus in the middle. Yep. Now, we're going to take an x out of here. And then what do we factor this into?
X minus 4 plus x minus 3.
Good. Okay. Let's first do the denominator. You already have it factored. Let's come do your domain, your denominator. So, when x is 0, when x is 4, when x is 3. Take them out of your domain. Let's build a little domain thing here. Here's my 0, my 3, my 4. So my domain goes negative infinity to 0. Then what? Get this little section. 0 to 3. Then what? Good. 3 to 4. Then what? 4 to infinity. That's a lot. A lot of segments there. A lot of intervals. So we had to jump over all those parts. Now, let's factor this guy. What factor can we cancel out of here? X minus 4. So let's pull that down here because this is going to be my point of discontinuity. I'm still not allowed to use when x is 4. So x minus 4 equals 0. That's my factor. So let's rewrite this. I am left with x plus 2 over x minus 3. Now, what should we do next? Okay, you want to plug in the 4 into this so that we can find what our y is. So we're going to use this guy, and we're going to put 4 plus 2 over 4 times 4 minus 3. This gives us 6 over 4. Do you want to keep it as a fraction or a decimal? Fraction. So 3 halves is y. So here's your point of discontinuity. This is your point of discontinuity. Now, how about we do your asymptotes next? Work on your verticals. Work on your vertical asymptotes, because I'm going to ask you in a minute what your vertical asymptotes are. Where are my vertical asymptotes coming from? My numerator or my denominator? Denominator. So let's take this and set them equal to 0. And put them out here. Where is x equals 0? On the origin, but what axis? Y. Good. Because it's here, it's here, it's here, it's here. So here's my x equals 0. And here's my x equals 3. Okay, that's going to help me graph. Let's look at your horizontal asymptote. My degree in my numerator is less than the degree in my denominator. So what's my horizontal asymptote? According to your sheet, y equals 0. And where do I find y equals 0? On the x-axis. Good. So now, I put the original function, rational function, into my y equals with parentheses, and now I can kind of sketch this. I can see that it goes like this. I can see that this one's going down here somewhere, and this one's coming across here. Now, my point of discontinuity is if this is 3, it's in the 4 somewhere. I don't know, somewhere about here. There's your point of this. My graph is a little bit off. There's your point of discontinuity. So just show it by a little circle. It's a place where the graph has to jump over that point. Okay? So, do we have any max and mins here? Uh-huh. Where? Let's say, is this in the 1, in the 2, or in the 3?
2.
Okay, 2. This gives us a relative max. We can find our relative max, and we can round everything to 3 decimal points. Remember 3 decimal points. Some of you are still fighting me on the 3 decimal points. And if in section 1, this guy jumped down here, it has to come back up to right along this axis. It might not look like that on your calculator. Your calculator, remember, can't show how close it is. If you look at your table and you look at those negative values of x, like -8, -9, you'll see it kind of go down and start getting closer and closer back to 0. This over here has to have a relative min somewhere. So I'm going to call that A, I'm going to call this B. In order for it to come back up, it has to have some kind of minimum, which you can find with your second min. It'll do that with your second calc min. It'll find it. And even though your line on your calculator might drop off, when you look for your min and you go far enough to the left and far enough to the right, it will find it. Or you can always even change your windows a little bit. So here's your minimum. It's got to come back up to that. It's got to use that asymptote as its guideline. Did we have a slant asymptote for this? So, do you think we can, after getting all this, we can find its range? So, where do I start? I'm going to look to the bottom of my graph, and I'm going to see from here to here, if this is my min, that's above this point, isn't it? So, on my bottom of my graph, didn't I at least come up this high? So let's start with that. Negative infinity to that y point. For 8, 1. That's 8, 1. 8, 1. Okay? Then what? I'm not going to use this card in here. I jump now up to here to this minimum point. What's this minimum point? Okay? Now, normally I'm going to stop and take out my point of discontinuity, which is over here. But do I have to? No, because look, across the way, he takes care of that point for me. So, up to this point and on up, I'm going to be continuous. I took a jump from here to here. Then this to infinity. There's your range. Okay? Normally we take out your point of discontinuity, but it's okay, it's covered on the other side, so I'm using that point. Someone else is taking care of it for me. Kind of like, remember when your one piece in the middle came all the way through the origin? We were supposed to take out that the 0, 0, but we didn't have to because your middle section came through. Okay, do we have any concaves? Concave up. Where am I concaving up from? Look at section 1. Give me the x values. To when? Where do I stop when I concave up here? 0. Good. Yeah? Where else am I concaving up? Okay, from 3. But I have to take out which point? 4. I got to take out 4. And then I can continue to infinity. I got to take this point out because you kind of blocked me. And do I have a concave down? From where to where? 0 to 3. Use that guideline, right? Kind of like on the highway there, from 0 to 3. Okay, don't forget this piece right here, taking that 4 out of there. And what else are we missing? Did we do your x-intercepts? X-intercepts, this is the zeros of my numerator. Come to see what's left. X plus 2. And I'm going to check that. It's this guy right here. Negative 2, 0. I can check it on my calc. And my y-intercept, when x is 0, I'm going to go back up here. It takes this one out. I've got a negative 8. And it takes out the whole bottom. Can I divide by 0? No. So I have no y-intercept. How's that? I'm not getting a lot of smiles out here. Is it
The next section.
the next section? This probably